Cool. Another thing that I really dislike is, or I really discourage, is patching of the kernel in the octo tree. Mostly because it makes the job of the kernel developers hard. If you have a bug and I want to reproduce it, I have to go and fiddle around with the octo tree instead of just building a kernel. But it's also, it's a whole host of reasons that it makes it a little bit harder. That bullet point about known offenders is actually really out of date. That needs to be deleted from this slide. Both MetaWitherspoon and MetaUntil don't have those patches anymore. I don't think MetaUntil does it? Who's an Intel guy? No, you don't? Yeah, cool. And MetaWitherspoon got their patch upstream, so good work to them as well. So current status, we're currently based on 5.2, which is the current released kernel, at least for one more week when 5.3 will come out next weekend. And we've got about 150 patches in the tree. They're all over the place. Most of them are in device trees, so we've got a whole heap for the hope of lines of code for the new SB2600 and a whole heap of lines of code for the Nuvoton device trees that aren't upstream yet. As far as drivers go, it's a bit of a smattering all across the place. The big subsystem that we still are carrying the OpenBMC tree is the PECI tree, a PECI subsystem that's kind of a work in progress still. This is my favorite graph. I love showing my managers. We started off with lots of patches and we've got less. I stopped updating it after 4.19 because it's just kind of flatlined. We've kind of stayed around 100, 200 patches, and lots of that code goes upstream, but then it gets replaced with new work as it goes. So our steady state at the moment is around that kind of 200 patch figure, which doesn't concern me too much because the code tends to flow upstream, except for the patches that I'll talk about soon. So as I was listening to Chris's talk earlier, I rebased against today's Linux Next, or yesterday's Linux Next, not today's. And luckily Linux Next is released in Australia by my colleague Stephen, so the date's for today, even though he did the work yesterday. So we've got 75 patches outstanding. So that's pretty good work. Half the patches that are in the tree have been sent upstream for the next kernel release. So when 5.4 comes out, they'll all be in there. And that's, that makes me happy. So what do we got upstream? A lot. Not worth going through it all. Most of the code we boot when we run a BMC is in the upstream kernel tree, and there's plenty of. So I know that Romulus can boot without any upstream patches, and I'm sure there's a whole lot of other systems that can as well, which is pretty cool because it means I can retire on a beach. No. It means that there's less work to be done on kind of just carrying patches from release to release, and more work that can be done on making things go faster and cleaner and all this kind of gear. There's two kind of patch sets that didn't quite make it upstream for this release. That's the PECI patch set and the XDMA patches. Hopefully they'll make 5.5. And the other one that I've kind of been perpetually at the top of my to-do list is implementing getting the hash crypto engine upstream. If you've ever watched a BMC boot, we load the fit image, and then it does a char verification of the payloads inside the fit image, and that takes a pretty decent amount of time, especially on a 2400. And the airspeed does have acceleration for that in Silicon, so we could potentially take advantage of that. If anyone wants to pick up that work, come speak to me afterwards. On the Nuvoton side, there's a whole heap of code that's gone upstream in the last kind of couple of years, which has been good to see. And then there's more, yeah. Avi is going to add to my list for me later. Excellent. And recently we enabled one of the Nuvoton machines in CI, which is good because now we know when I break it, and more to come hopefully as well. Something that I didn't know if it was the right thing to do when we started was having all the device trees upstream, but it's working pretty well so far. I'm not sure at what point the upstream maintainers will go, maybe you should stop doing this. We're currently at about 27 machines in the upstream kernel tree, and I'm sure there's more to come. Does anyone carry their device tree patches out of tree? Boo. Send me a patch, Chris. Yeah, it's pretty lightweight getting in there now, especially if you're using all the upstream drivers. There's no reason the patch you're using currently can't just go straight in. Yeah. So old patches. This is kind of the naughty list. The first two are owned by my colleague Andrew back in Australia, so he's going to love watching this talk later. The maximum fan controller is pretty broken and has some hacks in the tree that probably will never go upstream, so we'll carry that for a long time, unfortunately. The one that we're all kind of interested in, but I think on the Nuvoton side and the ASP side, is kind of this missed reg driver. So our BMCs, as you know, have a hope of registers all over the place for doing tricky little things that don't really fit into any kind of kernel subsystem. And we need some way of exposing those. And currently we have this device tree-based kernel driver that exposes just any old register you want to user space. Probably not acceptable upstream. We haven't actually tried, but that needs a bit of work done and something kind of created there so that all these different knobs and switches that we want user space to be able to touch, but we don't want to use devmem can still be exposed. The other one I was just talking about a few minutes ago was SPI NOR. So we have SPI NOR upstream, but it doesn't have the link training, so it doesn't go fast. That's carried in the OpenBMC tree. And in between when we first got those patches in and when we wrote the link training, the upstream maintainers said, we're not going to support SPI NOR anymore. Nuvoton had a great time with that, where they wrote their entire driver and then it got knacked and they had to rewrite it. So that's not cool, but it is the reality as it stands at the moment. There's another subsystem called SPI-MEM that we have to rewrite the driver for. Unfortunately, SPI-MEM lacks the APIs for doing things like the link training, and so they asked us to do that. We're like, what? We've already got patches that do it, and we just haven't had time to do it. So if anyone wants to become the new ASP SPI flash driver maintainer, come talk to me afterwards. But yeah, it would be great to get that code upstream, particularly because as the upstream support becomes more complete, people do take the upstream kernel and try and use it on their system, and then wonder why it doesn't work. I was following some of the ORBoot work on Slack the other week, and they were having troubles there, and I think it's because they weren't using the patch kernel. So that's SPI NOR. And finally, PCI, PECI, I'm not sure you pronounce it. That one got knacked because Greg wanted us to use configFS instead of sysfs for the config API. And so Jay needs to rework that or something. I haven't had a status update. Does anyone know how that work's going? Any intel people? No? Okay. Yeah, we need to get that one out because that's a big chunk of code that's annoying to rebase each time we go around. So new chips. I was over in our office in the Eastern States of Australia the other day, bringing up the ASP2600. So there's a dev board there, and all the snaky blue cables are the FSI debug link that we have for power systems we use for booting the host. IBM got ASP to put a bit of our IP inside to do FSI, and so I was bringing that up. But to get that going, I had to get the rest of the chip going. So we got the PinMux driver, we got Watchdog Ethernet, the SMP support. The clock driver is written but not merged upstream. But there's a hope of code that will be in 5.4 for ASP, which is cool. Dev 5.2 has even more, and so that's what we're using to bring up a BMC card at the moment, which is all going well. I couldn't sleep last night due to jet lag, so I merged eMMC support. So now you can use SD cards in eMMC with the ASP kernel if you like. And because we didn't have hardware until a couple of weeks ago, we added 2600 support to QEMU. So if you're using Cedric's QEMU branch, you can boot an ASP 2600 with SMP, which is kind of cool. So what's upcoming? The rest of the 2600 will be on my plate for the rest of the year. And once we've got that going, I hope to switch focus to do a bit of U-boot work or something, maybe ORBoot, no, probably U-boot. A U-boot story is pretty sad. We've been using the SDK since day dot, and some of the Google guys did some work in getting basic 2500 support upstream, which is cool. Late last year, we did a bit more work. We wrote an NCSI layer for upstream and fixed up the Mac driver and wrote an SPI driver as well. And so hopefully we'll get them in probably early next year. and then we can start using the Upstream U-boot and get off our ancient 2016 fork. The 2600 A-speed rebased on this year's U-boot release for that, so that's at least newer, but it's still a whole heap of out of tree code. So we'll work with A-speed and try and get that in the tree. If anyone wants to be a U-boot hacker, let me know and we can coordinate that work. The other one is, my perpetual goal is to get the patch queue down to 0 so I can spend all my time running instead of at a desk. Running's my hobby. So keep sending your patches upstream first, keep getting in the upstream tree, and I'll work on getting that queue of old patches down to 0, and then we can all retire our beaches. So that's all the prepared material I had. Like I said before, hopefully that's jogged your memory about all the issues that you've had with working with the OpenBMC kernel. So I'd like to have a bit of a discussion now. If there's any things you want to talk about.
So the eMMC support you added in 5.2, it's going to work with the AST 2500 as well?
Yeah, we've tested it on the 2500. It should work on the 2400. That's upstream in 5.4.
You mentioned rebasing U-boot, and you, as far as I know, didn't mention AST 2400 in the rebase, and that is one of the things that is missing from the upstream. So in order to get to the current U-boot, would you drop all the AST 2400 platforms, or would you upstream that as well?
I think the current plan, due to lack of people, would be to leave 2400 on the SDK and move everything else forward. The gotcha there is the SDRAM training code. So Maxim from Google wrote the training code in C for the 2500, and A-Speed have written a version in C for the 2600, which is great, but the 2400 is a big question mark.
So you mentioned you have 150 patches, and those are not upstream yet in the kernel stable tree, right?
Not yet.
So, and
well, half of them are.
Half.
Yeah, 75 aren't.
Yeah. So, and what is the delta between once the kernel patches are accepted into the Linux Next and still not in the stable tree, do we pull it out to our development branch, or we do wait?
Yeah, it's a great question. So whenever I do a rebase, so 5.3 is coming out this weekend. When I go back from my travel, I'll probably rebase the OpenBMC tree on that. And I'll go and do a bit of a check for what's in Linux Next. And where I can, I'll pull the Linux Next patches into our tree instead of the ones we're carrying. And then the ones that are remaining on top of that will be the other tree ones.
So do you wait for the release, or do you keep checking the next? And
so the way I work is I rebase on the stable release. I cherry pick back from Linux Next, everything that's in Next at that point in time, and then apply the remaining ones on top.
Yeah, but the Next keep growing between two release, right? So do you do in between rebase of the Next also, or you wait for the next release?
No, I'd wait for the next release. Okay. Yeah, we don't create trees based on Next or anything like that. Or so when I first started, I was kind of rebasing regularly, but it would create issues with reporting bugs. So I'm like, oh, here's my SHA of my kernel that's broken, and I'm like, oh, I don't know what that is. I rebased yesterday, so we stopped doing that, and instead only rebase every 3 months, so every upstream kernel release. I'm not sure how that works for everyone else, but that works really well for us.
Okay.
Yeah, there's one big chunk of code that's was not in your presentation. I was wondering what the status was the JTAG subsystem. I think there were 16 rounds of review on the mailing list.
I don't know why that wasn't merged.
No, it just stopped.
Yeah, it just stopped. Are you the person that worked on it?
No, we wanted to use it.
So. We should resubmit it. I thought it was good to go as is. It was getting nitpicked, and I thought it was ready. So I'm, if you want to grab the patches and resend them, I'll act them.
Okay.
Previously.
So do we have a list of
A-speed device drivers which are not upstream? Do we know whether someone is still working on that?
We have a list. It's on the wiki, and it's horribly out of date.
Okay.
I was going to put a link in my presentation, and I read it, and so I didn't put them. So we can create a new list. There's nothing on my radar that needs to get done. So all the IBM systems, the drivers that we know we need, are already in the tree. But I realized that we only use a subset of the A-speed chips, so I assume there's other drivers other people want. So yeah, I'll update the list on the wiki, and the wiki is editable by everyone. So please add your things to the list and add your names against the things that you plan on working on or your team plans on working on.
Okay.
Have you talked to A-Speed about getting publicly accessible data sheets without NDA? Is
Yes.
that happening?
No.
No, not happening. Is there something that we as a community could do to persuade them to reverse that
We
decision?
could keep asking, but initially they said yes, but there was a misunderstanding, and the answer was actually no. So whenever I write code, I document the registers as much as possible. I put all the defines in for all the registers, even if the driver doesn't use them, and things like this. In between the QEMU implementation and the kernel, it's all the bits of hardware we have code for are very well publicly documented.
Would it make sense to put together sort of a community? Sorry, would it make sense to put together a community-maintained data sheet that just aggregates all that information from various sources? Maybe for people who do not have access to the data sheets to just go through the public accessible sources and do that.
I like the idea of more of accessible information. I'm not sure what we're allowed to do and what we aren't. But yeah, is there you've come across stuff where you needed access to the data sheet and you don't have it, or other people? Or?
Well, I know the data sheet is floating around. The data sheet is floating around on the internet. So
Okay.
Anybody who's ever needed it does have it, but it seems like kind of a not great situation.
Yeah, I'll bring it up next time I talk to A-Speed. But
Also for the 2600.
yeah, does Novaton release their data sheets? Yeah.
If they will publish, if A-Speed will publish, maybe.
No, currently not, because we're trying to get our own advantages. So I think this is the same situation, but
Yeah.
they're catching up on us. So
It would be a competitive advantage to publish, because then people would be buying a chip.
yes. No, maybe for current generation, it is
Yeah.
a good practice. But the next generation is still hidden.
Oh yeah, I understand that. Yeah.
Okay.
I was really surprised that I was allowed to publish all the A-Speed code, but they were happy with me writing it, I guess. So who's used QEMU to boot the kernel? That's not enough hands. QEMU is awesome. Some people think that QEMU is not necessary if you have hardware. I say bollocks. You can boot a kernel in QEMU fast, quicker than you can TFTP it over to your hardware. And setting up hardware JTAG is far more frustrating than attaching GDB to your QEMU session. So I highly recommend next time you have something that crashes in the kernel, or next time you're trying to do some development, have a go at QEMU. We have a really high quality model upstream, to the point where the QEMU maintainer points to the A-Speed model as an example of what to do, which is great until you're working on the A-Speed model and you want an example of what to do, and you've got nothing to refer to. So yeah, get involved. QEMU has this really sharp learning curve, and once you get over that hump, it's really easy to use. If you feel like implementing a model, have a chat to me. Doing I2C models is super easy. You run I2C dump on all the registers in your device, and you stick them in an array, and all of a sudden you've got an almost functional model for most drivers. And you can add a little bit of smarts on top of that. Things like this are super trivial. Then there's more advanced things, modeling Ethernet, modeling our FSI debug stuff that we're currently doing, all this kind of gear. The goal with the QEMU stuff was both to help low-level developers, kernel U-boot, but also to help integration testing and continuous integration of the entire BMC. So if we have a complete model of the system, you can boot OpenBMC. And as I said yesterday, in CI we run the Romulus model all the way through to BMC ready state, and if it doesn't get there, it fails CI. So we're currently using it a little bit. The next step would be to try and do a power on, and we've done some experiments hooking up a PowerPC QEMU to a ARM QEMU and booting both firmwares. It's kind of a work in progress. If anyone else wants to run ahead and do that for Intel platforms, that'd be cool. So yeah, QEMU's fun. It's really useful. Jump on board. So we have Upstream. We have the ASpeed, the OpenBMC QEMU tree, and then we have Cedric's work. And Cedric's really good at sucking in work in progress patches and keeping up to date. It's no one's job at the moment to merge that into the OpenBMC QEMU tree, so I'd recommend looking at Cedric's. But we upstream that regularly. Another 12 patches went out last night, so I had GPO controller support, which is kind of a big step towards being able to do a simulated boot of the BMC and the host, because now you can script GPO interactions from outside of QEMU. So yeah, hopefully one day the answer will be apt-get install QEMU, but at the moment, go grab Cedric's tree.
Are you still accepting new patches, cherry picking from that upstream and to our dev?
Yeah, continually. It never stops. Yeah, sorry, I didn't quite understand.
So like my question is, like, if I have something on the next and I want to pull it to our dev tree, so we can just send a request for those patches?
Yeah, either if it's hard to backport, backport it yourself and send the patch to the mailing list.
Yeah.
If it's trivial, send me the SHA and I'll cherry pick it in.
Sure. All right, thanks.
So I'm wondering what kind of testing has been done when you rebase to the next version? Say maybe in 1 or 2 weeks we'll have 5.3 available, right? We'll try to publish dev.5.3 tree, then...
Sorry, excuse me. Sorry. Sorry, I was listening. How much testing do I do? I'll boot it on all the machines I have available. So I'll boot it on a Witherspoon and I'll boot it on a Romulus. So that kind of covers the UBI-based system and the raw NAND system and QEMU. So that's testing I do. Usually before I bump to the new one in OpenBMC, I'll send out that announcement to the mailing list. And I know you're really good at replying to those and running on your systems, which is great. Encourage everyone to do that. Yeah. If you've got ideas for more kind of automated testing and whatnot, continuous integration of the upstream kernel is a pretty hot topic at the moment. There's a 2-day hackathon at the end of Plumbers, which is next week in Portugal, where we're going to do some work on kernel continuous integration. And so if we had more tests that made us happy with the upstream kernel on BMCs, that they could go into that project.
Okay, the reason asking is I try to think about I'm not sure if anyone tried to compile some LTP test code for ARM and try to run it on BMC and what the result would be.
I've never played with LTP, but that would be cool. And if someone got that going, I'd certainly add that to kind of my suite of things I do before I push to bump in OpenBMC. Yeah. Right. Have you played with it at all?
I tried. I went through some for CPU scheduling and memory management code. It's written by C. It looks like it's pretty general, but I haven't tried because I have to copy that to some meta layer and create a recipe file. That's why I'm asking if anyone in the community have tried that.
Yeah, I think that you can build LTP as part of build root. So no one has a layer for doing LTP as part of Yocto. I'm not a Yocto person, sorry.
Yeah, but yeah, maybe we can follow up later.
Yeah. Let's chat about it later.
Yeah.
I like where you're going.
Thank you.
Is there something for patching new drivers you helped us at the beginning to do that, and now customers or ODMs are asking us, and we have our own how-to that based on all kinds of things, but is there something that well documented?
So for submitting patches to the tree?
Yes, first for new drivers mainly.
Yeah. if I don't know how to use my web browser, sorry. No, it's gone. On OpenBMC GitHub, so github.com openbmc/linux/wiki, there's a bunch of tips and tricks and development process there. I recommend you use that. I try and keep that up to date. It hasn't been touched in a little while, so if you find omissions or information that doesn't look right, get in touch and I can update it.
Okay.
Yeah, I'd love to see patches from your ODMs and whatnot.
They do.
Yeah. Cool, is that it? All right, I'll be around the rest of the week. Come chat to me. Happy to have discussions about whatever else you want to talk about. Thanks for listening.